Part C, find the number of units that must be sold to maximize revenue. Again, we saw the function equation has a leading negative coefficient, the coefficient that's in front of the squared term. So we know this is a parabola that opens downward, so we have a maximum. So let's find that maximum. That just means we need to find the vertex first. So remember, that's the formula, negative b over 2a. So we have b is 100. So we have negative 100. And a is negative 1/4. So negative 0.25. So if we do this math, this will tell us that 200 units is the number of units that must be sold to maximize revenue. So determine the maximum possible revenue. So that means we go to the revenue equation and evaluate it when x equals 200. So that would be negative 0.25 times 200 squared plus 100 times 200. So again, that would definitely be a calculator time for me. So I can go grab the equation I already typed in, and everywhere I see a 150, I will just change that to 200. And that would be a quicker way to evaluate, because I've already typed in. So that looks like it'll be $10,000. So confirm this graphically in part E. So we found the maximum is at 200, and the maximum revenue is 10,000. So we can see that that lies at the maximum part of the curve, or on top of the parabola. And remember, we also found what the revenue was for 150 units sold, and that looks like it confirms our $9,375 there. So now part F, determine the price that would have to be charged in order to maximize revenue. So this is a little tricky, but it's asking exactly what the price function will give us if we use the maximum x that gave us the $10,000 in revenue. The x value was 200, but now we need to go to the price function, the p of x, and remember that was 100 minus 0.25 times x. So we're just going to evaluate this at 200. So p of 200 equals 100 minus 0.25 times 200. Now a quarter of 200 is pretty easy to do. It's 50, so I can do 100 minus 50 in my head. So that would be $50 per textbook.